ahead and get started then. It's chapter 4, if you guys don't have any more questions. Don't forget to write down the attendance code and make sure you do the attendance either now or do it later. All right, guys, so we're starting with lesson 4.1. This is our last chapter for this class. And I've been having issues with my stylus. Try this one right here. Okay, perfect. Okay, so we're moving on to lesson 4.1. And in lesson 4.1, we are discussing the exponential functions, guys. The exponential functions. When we look at the exponential functions, we're looking at functions in the form of f of x is equal to a times b to the x power. Or if you were to write this as an equation, it would be y equals to a times b to the x power. Now, in the previous chapters, we've been working with the functions that we looked at had an x base. So now with the exponential functions, the x becomes the power. When we talk about exponential functions, guys, these are examples of problems that grow or decline. Oh my gosh, I just realized that. Very rapidly. Oh my God, this is the perfect time to be talking about this. I'm going to talk about the exponential functions. Wow. Okay. So guys, when we talk about exponential functions, what you have to understand is that these are things that grow or decrease very rapidly. So we got exponential growth, or exponential decay. The one that we focus on primarily is the exponential growth, but we will also be chatting about exponential decay. Now, let me go ahead and give you some key components of these exponential functions. Here's a basic exponential function. F of x equal to 2 to the x, or y is equal to 2 to the x. Now, I am going to compare this to the quadratic function f of x is equal to x squared. So you guys can see the difference between the two, especially when it comes to the graph of y equals to 2 to the x versus y equals to x squared. Now, I am going to go to a table here, and we are going to make the comparison between 2 to the x. You know what? Let's do the x squared first. We're going to make a comparison between x squared, the x squared function, quadratic function, versus the exponential function 2 to the x. Now, rather than, you know what? Let me put 0 in here. Let me put in some values in here. 1, 2, 3, 4, 5, 6. I think 7 will take us to where we need to go. Hold on a second. I don't need this column. I don't know why I put the column in here. Okay, we don't need that. All right, guys. So for the quadratic function x squared, if I take 0 and I plug it in for x, I get 0. Now, for the exponential function, guys, if I plug in 0 in here and I do 2 to the 0 power, what does that equal to? What is that equivalent to? Anybody? Anybody? 2 to the 0 power, what is that? Huh?
Can you repeat the question?
Okay, the question is, if I take 2 and I raise it to the 0 power, what do I get? I get 1. David has the correct answer. So anything raised to 0 power is equivalent to 1. Now, if I take 2 and I square it, that's going to give me 4. Now, if I take 2, and that's the same thing, that's going to be 4 as well. 2 to the second is 4. Now, when we move on to 2 to the third, if we take 3 and plug it in, the 3, we're going to plug it into the x squared. We're going to get 3 to the second power, and 3 to the second power is going to give us 9. However, 2 to the third power is going to give us 8. Now, the next one, if we take 4, we square it, we get 16. And if we take 2, raise it to the fourth power, we also get 16. Now, guys, this is where things are starting to change. At 5, when x is equal to 5, 5 squared is 25, but 2 to the fifth power is 32. Right here, you will notice that the exponential function is greater than the quadratic function. Now, let's move on to 6. When we get to 6, 6 squared is 36. However, when you do 2 to the sixth power, you get 64. Now, guys, 64 is almost twice the 36. So as you can tell right there, when x is equal to 5, starting at x equals to 5, and then moving along, the exponential function value is greater than that of the quadratic function. And then if we go to 7, we take 7, we square it. Look at that, that's 49, but the other one is going to be 128. That's over twice the quadratic function. So guys, once you go past right here, 5, when x is equal to 5, the exponential function starts growing or multiplying faster than the quadratic function. Now, if we were looking at this in terms of the graphs, let me go ahead and see if I can erase some of this so I can go ahead and graph it. Okay, I'm gonna graph some of this, guys. If we were to go on the xy plane and graph the exponential function. Now, for the exponential function, remember I plugged in some values in here, but when you graph it, the graph of the exponential function has a y-intercept at 0, 1. The graph is going to look something like this, guys, okay? The graph is going to be above the x-axis. It is going to intersect the y-axis at 0, 1. The graph is very, very close to the x-axis. However, it does not intersect the x-axis. And then once it hits the y-intercept right here, it just moves very rapidly, very quickly to the right. It increases very rapidly to the right. So the graph of an exponential function, some of you may want something to remember it, looks like a backwards capital L, if that's going to help you, okay? Hold on, let me let Evans in. Okay, very good. So guys, here are some of the components of the exponential function, okay? First and foremost, I've already told you that there is a y-intercept at 0, 1 for the exponential function. As in, when you substitute 0 into the exponential function, the corresponding y value is going to be 1. So there's a y-intercept, okay, at 0, 1. So as x is increasing, the value of the function is approaching positive infinity. So the graph increases from left to right. Now, let me write a little bit of notation on here and see if you guys can understand this. So as x approaches positive infinity, f of x approaches positive infinity. What this is saying is, as the x values are increasing, the y values are also increasing. So when you describe the graph, you say that the graph is increasing from left to right. All right, so I'm gonna pause here and I'm gonna ask you guys to give me some components. Okay, let me rephrase that, okay. What's the domain of this function? What would be the domain of the exponential function? In other words, what x values am I allowed to plug into this function? When is this function defined? Good morning, Evans. Anybody? Take a guess, guys. Don't be bashful. Take a guess, okay? Negative infinity, positive infinity. Very good, David. So the exponential function, guys, has a domain that's all reals. In other words, you can plug in any values of x into this function, positive, negative, 0, and always get a corresponding y value. Now, next question is the range, guys. What would be the range of this function? So when you're plugging in these x values, positive, negative x's into the function, what kind of y values, what kind of corresponding outputs do you get for this function? Take a guess, guys. You can type it into the chat box, or you can go ahead and tell me. What do you think? What would be the corresponding y values for this function? Anybody? All right, so guys, let's think about it. What happens if we were to take a number and raise it to a negative power, like -1? What would we get if we were to take 2 and raise it to the -1 power? What would we get? What's 2 to the -1 power? Anybody? Nobody? Okay, very good, David. All right, David. That's 1/2, okay? So whenever you raise a base to a negative exponent, that is indicating you have a fraction. So here, 2 to the -1 just simplifies to 1/2. How about 2 to the -2 power, guys? What would that one simplify to? Two to the -2 power, 1/4. Very good, Evans. How about 2 to the -3 power, guys? What would that one simplify to?
1/16.
Not 1/16.
Oh, 1/8. 1/8.
1/8. Very good. So what seems to be happening, guys, as you're raising 2 to a negative exponent? When you raise a base to a negative exponent, what seems to be happening with the y values? What's happening here? What's happening with the y values? The 1/2, the 1/4, the 1/8. What is happening, guys? Yes? Come on, say something. Okay, so just to move on, as you can tell, guys, as we're plugging in these smaller and smaller x values, very good, Megan, the y values are decreasing. They are getting smaller and smaller and smaller and smaller. They are trying to get to a specific value. What value are they approaching? What value is the function approaching as x is decreasing? Very good, Megan. 0. So guys, what would the range of the function be? Anybody? Type it up. Let me know. So what's the range? Okay, very good. So the range, according to Megan, would be from 0, not included, up to positive infinity. Excellent. So guys, the range of these exponential functions, by the way, I forgot to write this on the side, because this graph is increasing from left to right. We refer to this as an exponential growth function. Now we'll talk a little bit about it in a minute, okay? And remember, your exponential growth function is in the form of f of x equals to b to the x power. All right, now guys, that number that the graph is getting closer and closer to, in this case 0, what is that number called? That value that the function is getting closer and closer to. We just talked about it in the last chapter. What is that called? The minimum, not the minimum, try something else. And it's not just one value, it represents an entire line. What is it called, guys? When a function tries to get to a number, but it will never get to it, what do we call that number in the graph? And remember, that was in the last chapter we just finished, chapter 3. Anybody? Okay, so let's try it a different way. What you will notice, guys, about the graph of this exponential function, it gets closer and closer to the x-axis, but it will never intersect the x-axis. So the x-axis would be called what? Take a guess. Anybody? All right. Wow, you guys forgot so quickly. So the x-axis would be referenced as the horizontal asymptote. So this is a horizontal line, the horizontal line that this function is approaching, but will never get to it. How would we write the line as an equation, guys? What would the line be as an equation?
Would it be y equals 0?
Y equals to 0. Very good, Evans. Okay. So guys, all of these exponential function, they have a horizontal asymptote at y equals to 0. All right. Now, for exponential growth, guys, these mimic scenarios, situations in real life. Okay. I'm so excited to just talk about this part right here because I've been excited to talk about it for quite some time now. Okay. So these mimic things, scenarios, situations that multiply or grow very rapidly. Now, guys, your turn. You can either type it in the chat box or you can tell me, what are some real life scenarios of things that multiply or grow very rapidly? Come on, guys.
Stocks, Miss Sarah.
Stocks, very good. I will take that.
No, that's what you're waiting for.
No, that's not actually. I love this one, but that is not what I was waiting for. Come on, guys. Somebody. What are things that multiply or grow very rapidly? Come on. Somebody needs to get this. Cells, okay, I'll take that. Like bacteria. Somebody said people, as in population. Now,
I was
when we
going to say
talk
the
about
death rate, but that works too.
hold on a second. Population, as in the population of bunny rabbits. Population of ants. Ants outnumber people, okay? So yes, definitely population. Now, Evans was about to say death rates. Explain what you mean by the death rates.
See, there's a lot of people right now that are exponentially dying. And so if you were to graph it, you know, it would have been consistent at one point. Then around like, you know, the March, April section, it would have, you know, started to go up.
And what else is happening besides the death rate? What else is happening that could mimic an exponential growth function? Come on, you can do this, Evans.
Is this supposed to be something related to the coronavirus?
Guys, absolutely. Okay. Yes. Yes. Guys, listen, all you have to do is look at the television. People are actually using the terms, they're using the graphs. Okay. The number of cases are growing exponentially. The number of deaths, like Evans was saying, is growing exponentially as well. All right. Now, big question for you. Over the life of this period where the virus is running around rampant, is it eventually going to end up being just an exponential function, or is it going to be some other types of function that we've discussed? So in other words, is this virus going to continually increase over time, or is something else going to happen? Come on, guys. I've been so excited to talk to some of my classes about this because I'm watching this on television. I'm like, oh my God, that's an application of exponential growth functions. What do you guys think?
So wait, so you watched the
Wait a
news
minute.
just so you could get math questions?
Yeah.
No. I mean, I'm watching CNBC. CNBC is the stock channel. You know what?
Oh, okay.
Okay. But of course, the coronavirus is affecting every aspect of our lives. So obviously, they have to discuss it too. But guys, I'm going to tell you, I'm going to be real honest with you. I've been taking pictures of the television screen when I see stuff like this, okay? It's just so exciting to me that we are living through, okay, an everyday application of mathematics, okay? That's how exciting this is to me. All right, so going back to this, guys, okay, so right now, during this period of time from about December until about now, we are experiencing exponential growth because the rate of infection is growing, okay? It's growing incrementally. It's growing very quickly. At some point yesterday, I saw someone who says that it's growing by a factor of 2. Did you hear that? It's grow as in it's multiplying every 2 days, every 3 days, or something like that. It's doubling. That's exponential growth, guys. And same thing with the birth rate. I mean, not birth rate, the death rate, okay? It is increasing exponentially. Now, let me put a caveat in there. And here's the caveat, guys. Eventually, the virus will reach a plateau. It will reach an apex. So when it reaches that apex, what's going to happen with the number of infected cases, the number of deaths? What's going to happen with that? Come on, people, talk to me. You guys don't sound like you're as excited about this as I am.
Why would we be excited
Yeah.
that we can't go outside?
No, the mathematics.
Oh, okay. So we were excited of the math that we can't go outside.
Shazam. Man, I'm wasting my excitement. Okay. Okay, guys.
But to answer your question, at one point it would decrease.
Yes, it would start decreasing. So if you have a function, guys, that increases and eventually it reaches a plateau, it reaches an apex and starts decreasing, what kind of function is that? Talk to me. What kind of function is that? Come on, guys. What? Okay, let me do a quick picture for you guys. Quick picture. Okay. David said exponential. No, for a period of time, it's all exponential. But, David, once the rate of death or the rate of infection reaches the plateau and it starts decreasing, you have a function that looks like this. What kind of function is that, guys? Seriously? Come on. Okay, Megan said a parabola. Okay, we'll take that. That's a quadratic function, guys. That's a quadratic function. And so when you guys are in the classroom, you're like, oh my God, we never use this in real life. Here are some real life examples happening. We are actually living through it. Okay. And by the way, there's lots of movies, books that talk about pandemics or epidemics. Okay. Pandemics affects us on a global level. Okay. One of the movies I remember was Outbreak. There is one recently, I think it's called Quarantine. I don't remember exactly what it is. That lady from the Titanic movies in there. What's her name again? I forgot her name. Emma. Okay, Emma Watson. Okay, is it Emma Watson? It's some kind of Emma. Okay, so guys, listen. I've been so excited to share this information with you. I just couldn't wait to share it with you. So this is a perfect example of exponential growth during this time period that we're living in through the coronavirus. All right, now going back, of course, my favorite thing to talk about, all right, if we weren't living through this period of coronavirus, would be stocks, money appreciating. So we're going to go ahead and put a pause on the money for now, and we'll come back to it. So I can go ahead and address the other type of exponential function, okay? Remember, there's two types. There's growth and there's decay. Now, For exponential decay, guys, I'm going to give you this function right here. F of x is equal to 2 to the negative x. Now, remember, I just told you guys a few minutes ago, when you have a negative exponent, the negative exponent indicates what, guys? What does it indicate when you have a negative exponent? Come on. When you have a negative exponent, what does it eventually become? Come on, guys. Nobody? Guys, take a risk.
Fraction?
Go for it. A fraction. Very good. So a problem like this, we can rewrite it as 1/2 to the x power. That's still the same thing. And then the 1/2 as a decimal can be expressed as 0.5 to the x power. So guys, couple of things. There's multiple ways for you to express an exponential decay function. Now, I want you to notice though, be very careful. Just because the exponent is negative doesn't necessarily mean that it is a exponential decay function. We're going to talk about how you determine whether you have exponential growth or exponential decay in a minute. Now, the graph for the exponential decay, when you sketch it on the XY plane, is going to look something like this, guys. Right? When you sketch the graph, it will look something like this. Now, what you will notice for this one is that as x approaches positive infinity, f of x approaches negative infinity. In other words, the function decreases from left to right. Furthermore, guys, you will notice, once again, there is a y-intercept at 0, 1. In other words, if you were to take 2 and raise it to the 0 power, it would give you positive 1. Now, the domain is still all reals, and the range is still going to be from 0, not included, up to positive infinity. Now, guys, there is a horizontal asymptote on this one. What's the horizontal asymptote for this one? What's the horizontal asymptote? Anybody? Come on, guys. It's the same type of function. It is that number or that line that the function approaches but will never get to. So what's the horizontal asymptote on this one? Y equals to, give me the number.
Y equals 0.
0. Very good. All right, guys. Now, here's the big question. How do we differentiate an exponential growth function from an exponential decay function? Now, if you're looking at this one right here and you compare it to this one right here, both of the exponents are positive. So how can we tell if we have an exponential growth or an exponential decay function? The way we tell if we have an exponential growth or an exponential decay function is to look at the base. If the base is greater than 1, it's exponential growth. However, if your base is less than 1, but greater than 0, we call this exponential decay. All right? So guys, when you are doing these problems, you need to be careful. Don't just look at the power, oh, it's negative, therefore, this one right here is going to be an exponential decay. No, 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 no. Look at the base. If the base is between 0 and 1, as in the absolute value of it, don't worry about the negative sign. If it's between 0 and 1, decay. If it's greater than 1, then it's a growth function. That's how you know. All right, guys. So, quick question. Ooh, we can even apply it here too. So what are some examples in real life that would mimic exponential decay, guys? What are some examples? Real life scenarios that mimic exponential decline, exponential decay.
Stocks.
Stocks. Yes, recently, the stock market took a nice little tumble. It was riding way up here, and then all of a sudden it started decreasing over how long a period? 1 month, guys. 1 month. The stock market was riding way at 2,900. And then it went all the way down to like I think it was 29,000. 29,000 and it went all the way down to 19,000. So yes, the stock market in the case of money, where you're losing money. What are some other examples, guys, of exponential decay? Anything? Population. Population decrease. When you start losing a lot of people, when people start moving from a certain area, population. For example, endangered animals. The reason why they're endangered is because, why? There's a decrease in the population, all right? Another example, and I like this one so I could get to the next part of this. This one right here, guys, we talk about depreciation. Now, when we talk about depreciation, we are primarily talking about new cars. When you buy a new car, the value of the car starts to decrease the minute you drive it off the line, on the lot. So the car itself depreciates the fastest during the first 2 years of its life. And we're talking about the new cars. So you buy a brand new car, let's say this year in 2020, okay, most of the depreciation is going to happen during the first 2 years of its life. So guys, the value of this car is going to be way, way, way less in 2022 than it is now, okay? Some of you may not quite get that, but your parents get it. When they buy a new car, the value starts depreciating. So here's a nice hint for you guys, okay? As you get ready to start your own adult life, if you want a really good value on a car, what you should do is wait 2 years and buy a used car. That way somebody else has already depreciated the vehicle for you. And so when you go and buy that car, you get a nice discount on that nice car. And I know some of you are saying, well, I want the latest one. I want the brand new one. Well, guess what? The brand new one, okay, 2020, okay, that you buy in 2022 is going to look exactly like the 2022. Do you guys know why that is? Why would a 2-year-old car look exactly the same as a brand new car, guys? Anybody? Okay, here's why. The body styles of these cars, the bodies, they rarely change them. They change them about 4 to 5 years. And if you're talking about BMWs, it's even worse, guys. Rarely do you see a change in the BMWs. They take longer to change the body styles. So if you don't tell somebody your car is 2 years old, nobody's going to know. By the way, guys, seriously, it saves you a lot of money. So I would write this down, commit it to memory. When I get ready to buy a car, I'm going to buy a used car, a 2-year-old used car, a certified vehicle, used vehicle. And it works. All right, guys. So now let's go ahead and talk a little about transformations with these exponential functions, okay? Just quickly, I'm not going to spend that much time because I got to move on to the money aspects of this, okay? The transformations on these exponential functions. If you have an exponential function of the form a times b to the x power, okay, right there. If I want to move the function vertically, I'm going to add a c to the function. So when we talk about the vertical transformation, you're going to add a c to the function, outside the function. That's the vertical shifting. Now, if I have the same function and I add a value to the power, this value in the power moves the function horizontally. So this is a horizontal translation. And so when we talk about the horizontal translations, guys, remember you have to do it in the opposite direction, right? Now, of course, if I want to reflect the graph over the x-axis, the leading coefficient must be a negative. So reflect over x-axis. Now, if I want to reflect it over the y-axis, like we just saw with the exponential decay, then that's going to be the negative in the exponent. Reflect over or about the y-axis, about y-axis. So that's the negative in the exponent. And then last but not least, the a value, guys, determines the vertical stretching or shrinking. Vertical stretching or shrinking. So that's a quick review of the transformations when it comes to the exponential function. All right. Now, I am going to go ahead and move on. So for this next part, guys, we're going to talk about the application, money applications when it comes to exponential growth. Now, guys, listen and listen carefully. I wish more students were here today. This is probably one of the most important formulas you will encounter in a math class, okay? I am telling you, okay? Not everything in math class is that applicable, but exponential functions when it comes to money, in particular compound interest, this is one of the most applicable functions or formula you will encounter in mathematics, guys. So if you weren't paying attention, if you weren't tuning in, if you were still sleeping, okay, wake up and pay some attention, all right? Okay, I'm getting too excited because I'm about to talk about money. You guys know how excited I get about money. All right, compound interest. What is compound interest, guys? Now, this is all about investing. Why do we invest money, guys? Come on, everybody. Why do we invest money?
So it comes back to us in the future.
Say it again.
So it comes back to us in the future.
Okay, give me something else. Give me something else. Why do we invest money? What is the purpose of investing?
So it can grow.
So it can grow, to make our money grow, so we can make more money, okay? So one of the ways to make your money grow really fast, you know, exponential growth, or really rapidly, is to go ahead and use compound interest. One thing that you guys have, okay, one precious commodity you have on your side is time. The longer you have to invest money, the more money you will have. Here's how compound interest works, guys. Not only do you earn interest on the principal, you also earn interest on any interest you've earned. So you earn interest on the principal, interest, and you also earn interest on any interest you've made, okay? So guys, that way your money grows faster. Now, the formula we use to calculate compound interest, and I'm primarily talking about investments here, is A equals to P times 1 plus R over N raised to the NT power. A is the total accumulated value or the total amount in the account. P is your principal, the initial investments. R is your rate, and remember the rate, guys, is a percent. You got to change it to a decimal. And then of course T, the most precious commodity, time, okay, right here is given in the units year. All right, now N, I have to erase some of this so I can talk about N, because N requires a little bit more work. All right, I am going to erase this part at the bottom over here. And remember, guys, if you're missing any of this, it is being recorded. All right, so guys, now let's talk about N. N is the compounding frequency. In other words, how frequently is the interest compounded? And when we talk about compounded, How frequently is the interest calculated? How often do they calculate the interest on my money? Okay, so they could compound the interest or calculate the interest annually. So this would represent 1, n would equal to 1. Now, if you go into the formula right here, guys, okay, and you're compounding the interest annually, all the n values become 1. The formula is going to simplify out to just this. A equals to P times R, 1 plus R to the T power. So if the interest is being compounded annually, the formula from here simplifies to that, okay? Because all the n values are 1. Now, the interest could also be compounded semi-annually, as in every 6 months. So if it's every 6 months, how many times a year is that, guys? 2 times. Now, it could be compounded on a quarterly basis. If it's quarterly, how many times a year is that? Every 3 months, so that would be 4 times a year. It could also be compounded monthly. And then monthly would be 12 times per year. And then the last way they could do it is daily. And daily would be 365 times per year. Now, in some instances, they will use 360. The 360 is called the banker's rule, okay? Now, guys, in order for your money to grow the fastest, the best way to compound the interest on an investment is to go ahead and compound the interest continuously. Let me go ahead and erase this so I can continue. If we compound the interest continuously, we no longer have an n value, which means the interest is calculated all the time. So the formula we use for this is A equals to P times E to the RT power, AKA the Hertz formula. So this is where the interest is being calculated all the time, guys. So the more the interest is compounded, the more the interest is calculated per year, the more you earn on your investment. All right, guys. So now, here's the beautiful part. Okay. So let's say I have $2,000. I don't need this money for another 2 years, okay? No, 3 years. And I go down to the bank and I want to deposit this money into a bank account, like a CD. CD stands for certificate of deposit, okay? And a certificate of deposit is a type of savings account where you take the money and you put it into this account, you lock it away anywhere from 3 months up to 5 years. You cannot touch that money, okay? If you touch it before it matures, they will put a penalty on the interest you've earned, not on the original investment, okay? And I'm like, okay, I'm going to put this money away for 3 years. What kind of interest rate are you going to give me on the money? Guess what kind of interest rate they're going to give you. And I think we talked about this before in this class. What kind of interest rate, guys? Take a guess. Anybody? Come on, guys. All right. So on the interest rate, guys, listen, right now it's a whopping 0.01%. There are some banks that will give you 0.5%, okay, if you find the right bank. But most of the banks, they offer very low interest rate. But let's say you find a really good bank, like an online bank, like Ally. That's a good online bank. And they offer you 2% on your money. Let's calculate how much we have in the account, guys. If the interest is calculated annually. If the interest is calculated annually, the formula we use is A equals to P times 1 plus R to the T power. So we go ahead and plug in 2,000 for P. I hope you guys have your calculators ready because I'm going to need help with the calculator. 1 plus 0.02, and then I'm going to raise it to the third power, because I don't need this money for 3 years. Somebody throw that on a calculator for me, please.
It's 2,122.416.
$2,122.416, so that would be 0.42. So guys, at the end of 3 years, I would have $4,122.42 in the account total. So how much interest did I earn on the account? So take the 2,000, subtract it from the 2,122.42. So that leaves you with $122.42. That's how much interest I earn, because the interest is being compounded once a year. Now, let's take it up a notch. This time, we're going to compound the interest monthly. Monthly is 12 times per year. So if the interest is being compounded monthly, guys, we're going to have the interest calculated every single month. So the end value would be 12. The formula we use for this is A equals to P times 1 plus R over N to the NT power. So when we substitute everything in, we get 2,000 times 1 plus 0.02 over 12 raised to the 12 times 3 power. By the way, hint, 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 when you're doing these on your calculators, guys, it may be best to go ahead and do the work with the 12 times 3, which gives you 36, and then use the 36 power when you type this into your calculator. So who typed it into the calculator? Who has the answer for me? What's the answer, guys? What'd you guys get? Anybody? Come on, guys. You have to help me out here because I don't have my calculator in front of me. Nobody? All right, guys. So in order for me to go through this very quickly, I'm going to need help with the calculator situation here. All right. I'm going to need you guys to be typing some of this into a calculator. So nobody did it? Or are you guys not sure of your answers? Uh-huh.
I don't think this is correct. It barely went up.
What'd you get? Tell me what you got.
2,123.
123.
0.56.
Okay, now, I'm glad you brought this up. Why do you think this is not correct? Because it barely went up. Why do you think that's not right? What did you expect? What were you expecting?
A big number?
Like what?
I don't know.
$5,000?
I guess.
No, it is correct, actually. Yep, it's correct, guys. Okay, so let's compare. The previous one, when the interest was being calculated once a year, was $2,122.42. Like Elizabeth just said, well, wait a minute, Ms. Alcer, this barely went up. It only went up by $8.14, Ms. Alcer. That's nothing. Nothing, Ms. Alcira. So guys, listen, it did go up. It just didn't go up that much. Now, the other thing you should consider is this. If we were just using simple interest, where you're just earning interest on the amount you invested, this is how much you would have had in the account, $2,120. So if you're comparing it to this amount right here, obviously, you've made a little bit of money, $3.56. Now, some of you are saying, well, wait a minute, that was only $1.14 more. What am I going to do with $1.14 more? What could you do with $1.14 more, guys?
Get a Snickers.
Yes, get a Snickers bar. And I think some of you could use that right now because you don't sound like yourself, some of you. Okay? Don't take this the wrong way. I'm just saying you guys are sleepy. That's all. Okay? All right, guys. Now, get a cheeseburger. Is the McDonald's cheeseburger still about $1?
They're still $1, yeah.
Okay. All right. So McDonald's cheeseburger. What about a McChicken?
It's still $1.
That's still $1, not $1.59? Well, I know Wendy's has a dollar menu, definitely. Definitely.
I think it's still $1, yeah.
Yeah? Okay, perfect. So yeah, there are things you can do with $1. Get a small fry? Yes, absolutely. Okay, guys. So the best way for your money to be compounded is when the interest is compounded continuously. That way, your money, the interest on your money is being calculated all the time. So what if we were to go ahead and do this? Same account, same $2,000, but we're going to do it continuously. If we're going to do it continuously, the formula we use is A equals to P times E to the RT power. When we substitute everything in, we get 2,000 times E raised to 0.02 times 3 power. Now, guys, that E value, I forgot to mention it to you, that E value is an irrational number similar to pi. It is approximately 2.718. It is an irrational number that is primarily used in exponential growth and exponential decay type of questions, okay? Things that are naturally occurring. Now, the E value, do not memorize it. It is already embedded on your calculator. You can locate the E value right above your LN key. So you would find your LN key. Right above the LN key, you will see E raised to some power, okay? So make sure you guys can locate that button because you're going to need it to do these type of problems involving the PERT formula. So somebody throw that into a calculator for me, please, and let me know how much this is. What's the value, guys? A equals to 2,121. Probably 2380 something. Come on, guys. Remember, I need help with the calculator. Did you guys find your E value?
That is exactly what I was about to ask. What is that?
Okay. The E value is located above your LN key. So find the natural log key. Okay. Do you see it?
No, ma'am.
You don't? Okay. Do me a favor,
wait.
Elizabeth.
I found
What
it.
kind of calculator do you have? You have a graphing calculator, right?
Yeah, I found it. I found it.
Oh, you found it. Okay, perfect. All right. So Megan and David just told me the answer is $2,123.67.
Yeah, that's what I got.
Oh, well, you have the correct answer. You just didn't want to tell me because you're probably saying, wait a minute, that didn't do anything. It didn't move at all. And you're absolutely right, guys. But listen, over to 3 years, okay, if we are compounding the interest continuously, we've earned an additional $123.67 on our money. If that money was sitting under our mattress, it would earn $0. Actually, you would be losing money because the rate of inflation is probably more than 2%. I don't know what it is right now. Don't quote me around on that, okay? The rate of inflation, okay, Daniel is confused. I'm confused how you got that answer. The 2001-2367, Daniel? Okay, you gotta plug this part right here into your calculator. So you go on your calculator, Daniel, and you're going to type this into the calculator. So on the calculator, you would go ahead and do 2,000 times E, and E is above your LN key on the calculator. So look for LN, and right above LN, you will see the E button, okay? So you hit second, LN, and the E will pop up on the calculator, and then you type in your power, 0.02 times 3, hit enter, you will get your answer, okay? But you got to plug it into the calculator. All right. So, guys, here's the big question. Here's the big money question. Okay. Put a thumbs up if you're happy with earning $123.67 on your $2,000 over 3 years. Let me see those thumbs up. Okay, Ashley's happy. Okay. Anybody else? Come on, people. Oh, Elizabeth is happy. She's happy to make $123.67. Okay, Megan is happy. Oh, Megan changed the color on her icon. Oh, yeah, I mentioned that last time. So, guys, who's not happy with $123.67?
Oh, I know there was a not happy choice. Hold up, wait.
Can we make more? Is that what you're implying?
That's what I mean. You're not satisfied with $123.67. You don't want to settle for that. It's $2,000. In other words, could there be a way for me to make more money off my $2,000? Could I make more than $123.67? Still? What do you mean still, David? Okay, David, you're gonna have to speak up so you can elaborate on that part.
I think he was talking about like robbing a bank or something.
Oh, Shazam! No, David.
I mean, he's not. You know what? We'll talk about it some other time. It's us here.
I know he's not being serious. Okay.
I mean,
What
Yeah, I
is
feel you on that one,
another way?
David.
What are some other ways you can make more money off that $2,000?
Invest into more stocks.
Invest in what?
More stocks.
Okay. Invest in some stock. What do you mean invest in some more stocks?
Like instead of just investing into one company, invest in multiple.
Now, originally this money wasn't invested in the market at all. That was just
put
sitting
into
in
the
a bank account.
Oh, okay.
So a bank account is not necessarily an investment. That's just a savings account. Okay, when we talk about investments now, we're talking about money growing really nicely. Okay, so invest in stocks. What's another way you could have made $2,000 grow way more than $123? Not steal, David. Give me another example, guys. You make your $2,000 work for you. What's another example? Guys, there's lots of
Business or a
examples.
company.
Huh?
Owning a business or a company.
Yes, start a business. What are some examples of businesses you can start? Amazon businesses, affiliate marketing. Okay, you can buy some products from Alibaba and sell them on Amazon, people. Okay, what's another type of business you could start and make a whole lot of money? Okay, you could do a Depop. Okay, you could sell on Poshmark. I know people who go and buy used clothing and then they sell them online at a higher price. Now, there's people who buy sneakers like Nike, the limited edition ones, and they sell them at a higher price. So guys, there are ways for you to make more money of that $2,000. So let's say you were to purchase a pair of Nike for about $200 and you sell it for $500. That's a growth of $300, 150% growth. That's good money, okay? Now, let me talk about the stock market for a little bit. Even though you guys are really, really young, how old do you have to be to start investing in the stock market, guys?
18.
18. I'm sure I mentioned this to you before. Could you do it before that? Yes, you can. Your parents would have to manage the account for you, or they could set up the account and then let you manage the account, okay? Now, the stocks, guys. We have $2,000. If we had taken $2,000, let's say, what's a good company right now that's doing really well? Oh, let me talk about this one right here. Zoom, since we were on Zoom.
Oh,
Okay.
I was gonna say Netflix, but that works too.
Yeah, Netflix works too, okay? So you got $2,000. Let's say the shares of Zoom were $50 per share. And then you got 2,000, you divide that by 50, okay? How many shares of Zoom could you buy with your $2,000 at $50 a share, guys? Yeah, man. Come on, Sugar Plum. Anybody? Oh, come on, guys. 40 shares. Okay. So let's say you bought your 40 shares last year. By the way, the company just went public last year. It had its IPO, initial public offering, where people could actually buy shares in the company. So let's say you bought 40 shares of Zoom with your $2,000 last year. Right now, as we speak, Zoom is about $115 per share, guys, per share. So per share, you would have made a total of $65 per share. Now, you have 40 shares. So somebody do this, 40 times 65. How much profit would that be? Throw that on a calculator, guys, please. Oh, you guys are not helping me out with this calculator thing. 40 times 65. Oh my Lord, guys, look at this. Here, let me go ahead and write this in big old letters and red over here. $2,600. That's how much you would have made off your $2,000. In other words, you would have more than doubled your $2,000. Now, let me just say this. There's a caveat though. This is not always the case with the stock market, okay? Now, how do you know which stocks are going to do this? You don't know. That's why the stock market is very, very risky. There's a possibility you could lose some of your $2,000, or you could make way more money on your $2,000, guys. Now, right at this moment, because of what's happening with the coronavirus, many of these stocks, not Zoom obviously, they decrease in prices, okay? They're worth less than they used to. So for example, I've always loved Starbucks, but I never bought Starbucks. So the other day when the market was tanking, I'm sitting at home, I'm like, oh my God, Starbucks is at $54 from $100. I'm buying Starbucks. So I bought Starbucks, and now Starbucks is trading at $70 a share. So my little bit of money that I put into Starbucks is growing. Okay, here's an example. Teladoc. Teladoc is, do you guys know what Teladoc is?
No, ma'am.
Teladoc is telemedicine. Telemedicine. As in where a doctor comes on the screen and triages you. They ask you questions. They find out what's going on. They write a prescription to you. So in other words, you are meeting with your doctor online. It's also called telehealth. Okay, that was one of the companies I bought last year, $46 a share. Because of this coronavirus, Teladoc is doing really well. So Teladoc is currently trading at about $150 a share. And I bought it at $46 a share. So now it's grown to $150 a share. Now, guys, that is one way to invest your money to make your money grow for you. Your money doesn't have to sit in a savings account where it's barely earning any interest. And so the only money that should be sitting in a savings account is emergency money, money that you need right away, that you can get your hand on right away. So I hope you guys got something out of this, okay? Because I like it when young people start off really early in investing. There are lots of podcasts, YouTube videos that you can go and watch and learn more about investing in the stock market. Okay, this was just a little bit of exposure I'm giving you guys, all right? Unfortunately, we're not in the classroom. I would share some additional things with you, but we're not in the classroom. Now, if you are curious about investing in the market, guys, now is so much easier to invest in the market than ever before. Why? Because it doesn't cost a single penny for you to invest in the market. And plus, you guys have all these apps on your cell phones. Now, some of the apps I've used, they're better than others. Some of them, I use them for like a month or two, like Acorns, SoFi, Stash. They work for a little bit, and I'm like, wait a minute, I'm not liking this. So I gave up on them. But there's two of them that I use primarily that work really, really well. The two that I use to invest in the market, number one is Robinhood. Ew, They just sent me my little Robinhood debit card the other day. Look at that, guys. Can you see it? That's my little Robinhood debit card. Yeah, there's a bank. Okay. So anyways, Robinhood, number one. With Robinhood, you can only buy one share at a time. The second one, I have a card for that one too, but I can't get to it. It's on the counter. Okay, the second one is Cash App. So you guys know that you can invest in the market on Cash App? Did you guys know that? Okay, nobody knows that. Okay, all right.
I think there's like an investment like in the bottom when you first open it up.
Right. Let me see if I can quickly go into it. Now, if you go into Cash App, guys, at the bottom of Cash App, it has this little squiggly line in there. That little squiggly line, let me see if I could show it to you. Can you guys see it? That little squiggly line right there, you see it? That's the investment part of it, okay? So if you hit that little investment part, it will allow you to invest either in stocks or Bitcoin. So you want to go to the stock portion, all right? You want to go ahead and hit the search. And when you hit the search, you type in the name of the company, like Zoom. I just hit Zoom. So I'm going to go ahead and hit Zoom. There's Zoom right there. I'm currently, you know what? Let me not use Zoom because I'm currently invested in Zoom. This is not going to make my point. So let me go ahead and use something else. Let me do Teladoc instead. Teladoc medicine. Teladoc. Oh, they don't have Teladoc on here? Shazam. Okay, guys, they don't have Teladoc. Somebody give me another. Oh, let me try that one more time.
Spirit Airlines.
Oh, okay.
Yeah.
Okay. Why do you say, oh, I found Teladoc. Why do you say Spirit?
Oh, no, that's just my brother did.
Spirit Airlines is a good one too. Okay, guys. So here's Teladoc. Okay, that's Teladoc. And then if you scroll through here, they give you a chart of how it's doing. And then they tell you how much each share costs, $143 a share. Remember what I was just talking about? Now, let me see if they have Spirit on here. By the way, they don't have all the stocks in Cash App, but they have quite a bit in here. Okay, let me see. Spirit. By the way, just out of full disclosure, I started investing in Spirit recently because this company went from $54 a share. Here's Spirit Airlines, okay? And it's now at, look at this, guys, $14.38 a
Hold up,
share.
it's $14 a share?
Shazam.
I
It
think I got
went
those
from
14 somewhere. Hold
50 some odd dollars down to $14. By the way, when I bought it, I was buying it at $7, $8 a share, okay? Yeah. So the shares that I bought at $7 or $8, guys, they're now worth $14. In other words, I doubled my money, okay? And that was recently. All right. Ask me questions. Guys, I am telling you, this is probably one of the best ever conversations you're going to have in a math class. Okay? And I'm not just saying it because I love talking about money. I am saying it because students, people, parents complain all the time about how we do not discuss money in high school, but here I am discussing it with you. I talk about money all the time, anyways, but I am giving you good stuff that you can actually use and go and put into action. These are actionable steps, guys, okay? Whether you use Cash App or use Robinhood to start investing in the market, if your parents will not let you do it, you wait until you're 18 and start doing it, okay? Ask me questions. You guys don't have any questions for me? Okay, fine. So what I'm gonna do now is end the meeting, okay? Because I talked about exponential functions already. For those of you who wanna stay after and talk about money or talk about something else, you're welcome to go ahead